Hello. 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 Oh,
yes.
Hey. Hi. Thanks everyone for being here. I think we'll just about get started here. So you're in the right place if you're here for data-driven college counseling. My name is Mike DeSenza. I'm a data scientist at a college and career readiness platform called SchooLinks. Also, Katie Fang, our founder, is up here in the front, and we're really excited to be here and talk about data. So before I get into the actual presentation, I'll give you a little bit of background about me. Apologize if I go really off the deep end in terms of being a data nerd. I studied statistics in my undergrad and grad school at Columbia. Really love data. I've spent some time in the education space, more on the academic side. I built out actually a personalized learning solution for a charter school chain in New York, Success Academy. Spent some time in the private sector at JP Morgan and a digital advertising company. So really using big data there to solve problems with gigabytes and gigabytes of data, which hopefully you will soon have at your schools, if not already. And then now, what I'm doing is I'm actually working on the kind of non-academic side of things. At SchooLinks, we're really trying to understand motivation and college-going mentality and all of the steps that lead up to a student being successful in matriculating and going through college. So I lead a data science team here at SchooLinks, and we work very closely with counselors in districts on a number of different projects for them, and also provide a lot of data from our platform, SchooLinks. So I've spent a lot of time working with school data in the past couple of years. I actually wanted to just kind of get a sense of who we have here. So who is an actual counselor with a caseload of students? All right, and who's like more director counseling district level? Okay, couple. And middle school, high school, high school. And who considers themselves to be like a good Excel user? Very enthusiastic. Awesome. All right, so tutoring lessons up in the front and the right here. Okay, and who took a high school or a college statistics class? And who really remembers that statistics? Okay. Oh, again, same hands. Okay, cool. So we're here in this session. We're not going to go deep into the math. My goal is actually to help you understand how these different algorithmic tool sets can be useful for you. So I'm not going to have anyone come up here and have to derive something on the board. So we should be safe there. And then the last question I actually wanted to know from the group here, how many students are in your caseload, or how many students are you responsible for? So say under 100. 100 to 200. 300. Keep going. 400. Keep going. 500.
Oh my God.
6. Anyone more than 7? Oh, wow. How many?
750.
Wow. Okay. All right. So, I mean, the reason I asked that is kind of the next slide here. So, SchooLinks, we're a fairly new tech company. We have a lot of new technology. We got started in the last couple of years. And one thing, I want to start with a story here. One thing I always remember was this one discussion I had with a principal in Texas a couple of years ago. So we sat down and we were giving a demo of the product, and kind of unprompted, he came up and said, like, look, Mike, I think what you're doing is great. There's something I want to tell you. I really think this is one of the largest problems that my counselors have. My counselors get into the field of school counseling because they're really passionate about impacting lives and motivating children and helping them reach success, right? But what they get really frustrated with is that they feel like their job turns into becoming data processors. And so he used this word data processor over and over again. And I think that part of the reason that we feel that way is that we haven't necessarily positioned our use of data as necessarily a tool set to facilitate student success, and more as a task that we have to do. So I hope throughout the presentation we can start to consider, whenever we're working with data, we are still working toward helping students succeed rather than crossing off like an unrelated task here, right? Then the second thing I wanted to bring up is this idea of Dunbar's number. So this guy, Rob Dunbar, he was an evolutionary anthropologist, and he came up with this number, 150. So 150 is actually this scientific limit of the number of, I guess, reasonable social connections that you can keep in your neocortex, right? The part of your brain. It's the part of your brain that helps you remember context And if you were to say, I mean, the description of this number that he gives is if you ran into someone on the street and you you're going to go grab a drink with them at a bar, that's the number that of those people that it would be non-awkward conversation in the bar with, right? Slightly different scenario in school, right? If you have a caseload where it's actually like people who understand their own context, their own motivations, their course needs, their aspirations, right? And so Dunbar would contest that that is 150. For some people, like counselors with very large neocortexes, it could be much higher, right? But still, if you're working with 600, 700 students, it's really very difficult to keep in mind all this information. So that's actually why we use data. We actually offload some of our memory to the data side, right? And so I just want you to keep these things in mind as we go through the presentation. So today, and really what you should take away, one, we just want to, and I started on this in the previous slide, one, we just really want to make sure that what we're doing is expressing how useful a tool that this can be, and we're actually telling ourselves and our other counselors that using data is actually related to student success, right? Two, I'm going to go through some of the processes and the frameworks that I use when doing data science in the counseling setting, and hopefully these will be useful to you. And then three, which is where I want to spend the majority of the time, is actually going through the statistical algorithms that we use in our platform. You don't necessarily have to be using the SchooLinks platform. These are things that you can actually do or understand. That they're tool sets or things that are incorporated into other platforms as well. But you don't need to know how to do it. You need to know why they're important and how they provide insights that can help you. Lastly, so we're on Twitter here. So if you have any questions, I mean, we're a small group, so you can feel free to raise your hand and ask me as we're going through. But also, if you do have questions, tweet at SchooLinks, and at the end we'll go through and answer those. All right. So I want to actually, before we get into the actual data stuff, just pause here and talk about some of what we use data to solve and the goals that we're working with school districts on. So one of the most common things is as you would expect, increasing the number of students who have meaningful post-graduation plans, increasing college going rate, closing the achievement gap, also facilitating K through 16 accountability. So helping make sure that students both choose the right college and are able to stay in school through those 4 years and graduate. And then also enhancing college fit. Perhaps some of the goals that you're working this list, if they're not, I'd actually ask you to kind of go ahead and write down, if you have a piece of paper in front of you, what are the things that you're really focused on, and we'll try to, as we go through, apply what we're learning to those goals. All right, so you've maybe heard a little bit about being data-driven, or you find that compelling, which is why you're here, which is awesome. For me, I mean, since my background is in the private sector, I guess where I really encountered the promise of data and how it can help us reach our goals is in business, right? And in business, a lot of people refer to being data-driven as like the big data. The big data phenomenon is the idea that because there are so many more things that are connected to the internet, and that we're able to collect more data in a passive manner, we can actually have a much better ability to understand what's happening in a process. We can actually start to see and predict whether something will fail or succeed earlier in the process, and that allows us, if we're a business owner, to make an intervention and correct that process, right? The same thing is true in counseling. I don't necessarily think of helping students succeed as necessarily a business, but those are our goals. And the way that I think of using big data or being data-driven in both counseling and in the business world, I break it down into two parts. So one, there's analytics. So when I think about analytics, what analytics are basically it's surfacing data that allows us to understand intermediate checkpoints along the goal to a success point, right? What we actually it's cool because in the past, right, when everything was on paper or we didn't digitize a lot of the processes, we didn't have students do online activities, we didn't have this data to be able to surface these intermediate readings, right? And then second, data-driven research. This is actually more what I consider actually going in and understanding patterns that you cannot see on an individual level. If you're talking with students and you're like really, you have very good interpersonal skills, right? You can start to pick out and come up with these trends, right? But it's actually very difficult for you to explain to someone else why you think a student is going to succeed, or what about what they say to you makes you believe in them, right? And so when we're using big data to find data, what we're actually saying is, let's collect a bunch of data on a lot of students, and let's find statistical patterns and the levers, like the things that actually impact whether they're going to succeed or not, and try and apply that to other groups of students to lift up the average success rate. So I guess I kind of went through this slide again. Basically, with counseling, right? In the same way that we think of in the business world, this research and analytics, these two approaches, we also have that in counseling. And then one of the things that helps us get into the analytics and the research is we already have a lot of data, right? That data is data that actually you use already to do your job. So that is keeping track of, your understanding of where a student's at, your record keeping, the things that you use to overcome your Dunbar limitation number. And that is actually the raw material, along with other data that we have in a school, that helps us start to do this data-driven work. So what I'm going to do now quickly is go through kind of the specifics of an analytics project, and then the specifics of one of these data research projects, and then we're going to do an example of the data research project. So we'll actually pull up some spreadsheets, right? So first with the analytics, right? So we wrote down our goals before, right? So our goals are more qualitative, right? But to get into a setting where we can actually use numbers, what we want to do is we want to define those goals in terms of actual trackable numbers. So if you're doing something like saying, okay, we want to increase our college retention rate, let's set an actual benchmark. Let's set a number of, say, students that will graduate after 5 years of college or 4 years of college, right? Then once we have those goal metrics, is the fun part, right? And this is actually the part that I imagine most of you in the room are better at than I am. Coming up with these intermediate process tracking metrics, KPIs, or key performance indicators. So these are the things that if a student, say, fills out FAFSA by a certain time period, that their probability of getting into a four-year university is increased, right? So these are the things that actually indicators. You are able to track these, and you want to track these and report out on these on a regular basis so that you have some sense of, in an aggregate, how many of your students are going to reach these goals, and also on an individual level, who has failed to reach these checkpoints, right? Seems fairly straightforward, but if you don't have the right system in place, or you're not consistently going back to those metrics, it does make it easy for students who didn't meet some of those to kind of slip through the cracks. So obviously, the data that we use to come up with these metrics or to surface these checkpoints, that doesn't come out of the ether. We actually have to find that data or assemble that data ourselves. So session I'm gathering or creating data, so this might be repeating a little bit of it if you're at that session. But I think of our data as coming from two potential sources. One, existing data. Actually, schools are very data-rich environments. And as long as you know the people to talk to and how to access that data, you can actually get it out of an SIS by talking to the IT department or requesting permission, right? And then also, if you use college tools such as SchooLinks or Naviance or any of the other tools that are out there, be sure that you're managing that data in a way that helps you understand if your students are on the right track to progress. Then the other thing is, your SIS isn't going to tell you your student's college sentiment. They're not going to tell you what a student thinks about going to college. You also have to get a little bit creative in coming up with survey instruments or activities or basically, the learning that we ask students to do, it kind of leaves a paper trail. And if we're smart about capturing that, we can actually use that to build our KPIs out of. Some of the best practices for both creating our own and using existing data are making sure that we pay attention to this idea of an ID space or a primary key. Is that familiar to folks at all? I saw some nods. but for those of you that haven't encountered that before, this is basically how we are able to see that a student in one data set, the row in one data set for an individual student is actually corresponds to the row in another data set for that student. So in our example, we'll go through specifically how that works. Now, the other thing that's important is understanding the data generating process. And that's just a fancy word for saying, or fancy phrase for saying, like, we really want to understand who we have data on and who we don't have data on. If there's a set of students that actually didn't do the activity that was supposed to generate the data, or a set of students that you don't have information on from your SIS, you really want to understand why that's the case, right? Because if you understand that it correlates with the outcome that you're trying to test for, you're trying to predict, then what's going to happen is you're going to understand that your results are going to be very biased, right? So it's understanding really some data and why are we missing some other data. And then lastly, I wanted to bring up FERPA, right? So FERPA sometimes seems like the elephant in the room, right? When you're working with student data, you got to be cautious of student privacy. But I actually think, and this is something that we've realized after working with a lot of student data over the past couple of years, is if you read FERPA, FERPA is actually, it exists to protect access to student data, right? It indicates that this is actually a really valuable asset, and that we just need to be careful in using data in the right way. The other thing about FERPA is if you're ever encountering situations where you're finding it difficult to get access to data that you're not the owner of, and someone says, oh, it's because of FERPA reasons we can't release this data. Actually, FERPA does not cover anonymized data. Kind of data research and you're looking for patterns in that data, you actually don't really need the student's name or any identifying information. You just need to be able to tie those data points to other data sets, right? And you can do that with this ID space so that you can still tie the rows together, but you don't know which student it corresponds to. All right, so lastly, you've done all this work, you have your data, you have your KPIs. How are you actually going to display your KPIs? There are a couple options here. One, what you're probably going to do if you're using Excel is generate a report. And a report is just something that you'll go through a procedure of assembling these statistics and you'll look at them periodically. It's really good. It actually makes you take the time out of your schedule to take a check in and say, how are we doing? What are the students that are falling behind? How on aggregate are we going to toward meeting our goal? What you can do, and which is actually more useful in a lot of cases, is create a dashboard. And the distinction between a dashboard and a report is a dashboard is something that you can look at any time. In your statistics, your KPIs are actually quantified for you. You don't have to do any extra work, and they just show up. The drawback is it's kind of hard to make. There's some software that you can use, and you can set it up and do it for you. Or if you're using third-party solutions, or you're using some kind of system in an SIS, or even something like SchooLinks, we have a lot of these dashboards that we've already done the hard work and the heavy lifting to combine that data and surface the most important insights to you. I'm going to kind of skip through some of this. The next thing is the data-driven research. So if you look at this figure on the side here, it might remind you of a middle school science class, and that's actually not a coincidence. So when we do data-driven research, we're essentially following the scientific method. We are coming up with hypotheses and trying to validate that the data will show that there's a relationship between certain points of data and our goal outcome, right? And this will become more clear. So this is just, I'm going to go through quickly the process that I usually go through if I'm trying to come up with an experiment and I'm trying to learn about relates to student success, and I have a set of variables and I'm trying to parse out the patterns. Well, first, what I want to do is I want to make sure that I'm asking the right question. I'm not asking a question of my data that I could just read in a book somewhere, right? Because actually working with data and combining your data and doing calculations, it actually takes a lot of time. And if you can find out something that will help you perform better or help you take the right approach to help your students without going through this hassle, it's actually probably a good idea. If you are working with a very specific student population and you have reason to believe that, hey, working with this new tool set or new curriculum, it won't actually impact my students in the way that it's impacted other students, then you actually have found a good problem that you want to look into, right? And then is this. I'm just going to go directly to this last point here. So listing assumptions for validity. A lot of times, we're excited about combining data sets and seeing what insights and what variables correspond to each other. But a lot of the time, we also need to take a step back and say, what are some of the assumptions about how this data was generated, for instance? We talked about the potential bias in data. So if you're missing a whole, say, school's worth of data on a district level, and that school was not performing particularly well, and it looks like your treatment had everyone doing better, right? So just the way that I like to deal with assumptions is actually have someone else do a sanity check. So a lot of times, if you're working on a project, you're really excited about it, you don't really want to poke holes in it. But if you bring a researcher to a colleague and say, does this make sense? Hopefully, they'll be able to say, oh no, did you think about this? It might not work out, right? The distinction that we use, so as opposed to the KPIs and the actual goal metrics, when we're doing research and we're following the scientific method, what we're actually trying to do is we're trying to test an outcome variable, our dependent variable, which could be, say, the proportion of students that are going to a four-year college, against a number of treatment variables, which are our independent variables. So this is actually saying, okay, I'm going to test different programs or different curriculum or different approaches to college readiness and see if those treatments impact the dependent variable. Generally speaking, what will happen, though, is that your dependent variable and your independent variable are in different data sets. So this is why this key concept, this ID that we talked about, is important. Who was in the Excel session earlier, this is where you can use that VLOOKUP function. Take data that's in one spreadsheet and data that's in another spreadsheet and combine them so that you can actually analyze a full picture of the information around the student. If you use SQL or Python, which is more what my tool set, then what you're going to do is called a join. Excuse me. One of the other things that I think a lot of people skip through is graphing your data. Graphing your data is so important because it allows you to have a high-level picture of the trends that you'll see and also helps you identify outliers. So outliers are data points that are a little bit further away from where most of your data is. So the reason outliers are kind of important is when you're fitting statistical models, these outliers actually have a tendency to impact your entire model fit, right? Which is supposed to be representative of the general trend. But what happens is that outlier impacts the general trend more than it should. So that's why we like to graph data. We like to see, oh, if there's a data point out here and I can explain why it's different, I might not want to keep it in my analysis. Then when we're analyzing data, this is the precursor to our example here. One of the things that we use most often is conditional probability. Probability is all it is it's saying what is the probability of one event given another. And the example that I find is kind of useful is saying what is the probability of rain? Well, the probability of rain on any given day might be 10%. But the probability of rain given clouds is 70%, right? So when we condition an event on some other event, it has a different probability of happening. So we can actually do a lot of really powerful analysis if we just condition the probability of our outcome, which would be, say, students attending a four-year college, on a number of different other variables, and then we can test them against each other and see which variables have the largest increase in conditional probability. That's actually kind of it's one of the simplest approaches, but it's very powerful. I would say it gets you pretty much 80% of the way there when you're analyzing any data set. The other thing I'll say is, if you go outside, there's the Ask Making Data workbook. That actually is a really good explanation of how to do analysis like this. It'll walk you through step by step, a little bit slower than I'm trying to do here in over the course of the next 10 minutes. All right. This section actually, what do you do with your findings? I I actually usually defer to counselors, right? A lot of the analysis that I do helps them come up with different policy changes that they want to do in their department, or helps them understand how they want to change the way that they work with students. So I'm not going to spend time. We're just going to go into our sample project here. All right, so excuse me. So, so the question here we have is we have a school that is implementing a new self-study college, and they've done this for 2 years, and they want to see if this new curriculum has a positive impact on the amount of students that matriculate to a four-year institution. So what we have here to study this question is we have an SIS that actually contains information about whether a student matriculated to a four-year college, and then we have some separate records of the students that had used curriculum A, which is the original one, or curriculum B, which is the new curriculum. So what this actually looks like in spreadsheet form, or if you're to look in a database, is you've got your student ID, which is your primary key here, GPA, kind of unrelated, but is it really unrelated? We'll get back to that in a second. And then the outcome, whether they're in the four-year college or they're not in the four-year college. And then in our other table, we have our student ID, which is again our primary key, and which curriculum they used, A or B. So before we analyze this data and we start to actually calculate whether it had an impact, our first step is really combining these two data sets. So what we're going to do is we're going to basically take every row where there's student A, and we're going to take the treatment and the outcome variable and put them on the same row. So basically this is a kind of a fake data set, but we have, say, like 400 rows of this. And then when we've gone through that process, what we get is a table where we have the treatment, the intervention, right, and the outcome. And to calculate our conditional probability, actually, the thing that we need to do is just create what's called a two-way table. So that's up to the right here. And the two-way table, it basically gives us a count of the number of students that were in the A curriculum, and then what their outcome was. Did they succeed, or did they fail? Or did they go to the four-year institution, or did they not? And then we have the same thing for B. The conditional probability is we say, okay, condition on a student being in group A, right? That's the 111 students that did not matriculate to a four-year institution, and then the 33 that did. So we add those together, and we find the percentage of students to a four-year institution. So that's 23% in group B. And then what happens is we say, okay, it's 33%. So this is actually really all we need to do. And the thing that will make this powerful, right, is that we would actually do, so curriculum A and B is not the only thing that your students are doing, right? They also do a lot of other things, right? So we can actually, we can do more complicated analysis, like build in before we saw the GPA. We can say, we can control for GPA. If students in group A and group B actually had different GPAs, we can actually figure out the relationship that GPA has for the matriculation rate to some of the more advanced techniques. And that's what I can go through now, but I want to actually pause and see if there's any questions on the example here. Yeah?
So essentially, I think I'm on the wrong side.
Oh, I can.
I'm just trying to, there we go.
Yeah.
Just trying to like, my mind get the formula together. So it's essentially adding the failure. So one is a success and zero is failure, right?
Yeah. Oh no, yeah. Zero is failure, one is success.
Right. Not in such horrific terms, but
yeah. But in logistic in regression or like in statistics,
exactly.
That's what we think of it. Sorry.
And we're just dividing that by the number of success.
So no, what we're doing is we're coming up with the number of success, and we're dividing it with the total number that we're assigned that treatment. Yeah.
Okay.
So you're comparing the percentage of success in each group, and if you have a percentage of success that's higher in one group, that means that the treatment in that group was actually more effective.
Okay. Number.
Is there an ideal number?
Yeah.
So we'll,
like, I'm looking right here, like 22%, you know.
yeah, it's not very,
not,
that's not great.
It's like, you know, I'm thinking like, dark, but
Yeah.
like a standard deviation. Like,
Yeah, exactly.
Sort of like number we're shooting for that would.
Can we quantify how certain we are that this effect is real? Right? Yes. That's actually what we call like a p-value or statistical significance.
Exactly.
So that's actually, you're good. Okay. You're predicting the next slide. So that's one of the things that we're going to talk about. Yeah. Anyone else have any other questions? So now we're actually going to go through. This is what I think is the most fun here. So we're going to go through each of these statistical methods, and we're going to basically figure out how they could be useful for you. You don't have to know how to implement them. I just want you to, when someone says, "Oh, we're going to use statistical, or we're going to use causal analysis," I just want you to know what that means and know why it's valuable. So if you don't get that from any of the slides, raise your hand, and we can slow down and we can go through it in more detail. We'll start with classification. So classification is actually the technique that we use to determine whether a individual case, like in most of our situations, a student would end up in one of a number of different groups. Each case for this is actually figuring out whether a student will succeed or fail. I mean, I know that's not actually very helpful counseling language. That's how we think of it in statistics, right? Will it be in the outcome 0 or the outcome 1? What we can do, though, is we can have multiple outcomes. We can actually just create these different statistical models that tell us the probability that a student will either, say, go to a 2-year institution, a 4-year institution, a technical certificate program, right? And that would be an example of multi-class classification. Actually, what we did before, when we were looking at Curriculum A and Curriculum B, that is a form of classification because we were looking at a binary outcome. Did they succeed or did they fail? And I have another example here, which is we can actually go through it on a graph here. So the example is I want to predict whether a student will fill out FAFSA by a certain date, and I want to use their academic performance or their GPA to see if that's actually predictive of them filling out FAFSA. So this graph could be a little confusing, but I'll actually go through and interpret it. So on our x-axis, this would be our independent variable. This would be the thing that we're trying to understand the impact of. So this would be GPA down here. You have variable, you have instances of students that are spread out along that scale. And then on the y-axis, again, this might be a little confusing because there's only 2 values that your y-axis can take, which is a 0, which is a 1, or if they did not fill out FAFSA, that's a 0. Our goal is to really be able to say, okay, can I use the evidence that I have to one group or the other? And here you can tell that if I were to draw a line down the middle of this, it would actually misclassify some groups. But what I can do is if I have this curved line here, this actually indicates the probability at any given GPA, whether a student would fill out FAFSA or would not. I see no reaction.
Go for it.
I was going to say, so from a college and career standpoint, kind of using this model, would it be fair to use this if we had a scale of GPA from like 2.0 to 4 point whatever to try to predict which type of university or college a student might get into? So like 2.0 to 2 point something community college, 3.0 to whatever CSU, 3.5 at higher UC, would it be a predictable model using this to kind of to kind of show students that this, because of impaction, the reality of colleges is like, if you're looking to get into UC, you got to be at about a 3.8 or higher.
Yeah.
Would this be evidence to kind of support that theory?
Exactly. So in practice, this is the type of model. So in our platform, we have a machine learning algorithm that actually that we put in a bunch of input of students' data, basically historical data from a school about the admissions decisions on students from that school or that district. And what we do is we build a model that looks exactly like this, right? So we're familiar with the scattergram feature, right? Where it has data on multiple dimensions. What we're doing is we're taking in like similar data points, right? But we're building a statistical model that gives you the confidence that someone would get to that school or not get into that school. We actually, one of the things that we've done is we've said, okay, let me, instead of giving a statistical output of like confidence, where it's like, okay, 76%, because that doesn't matter very much, we put this through another algorithm, that, and I say algorithm, it's very simple. We say, okay, if your chance of getting in is 75%, we'll say, okay, this is a likely school. If it's between 75 and 25%, this is a target school. Below 25% a reach school, right? And so we actually use this type of algorithm in practice.
I'm trying to understand the visual that you got here.
Mm-hmm.
So what's each axis represent?
So again, this is the GPA on the bottom. It's a 0 to 10 point scale. You could make it a 0 to 4 point scale if you wanted. And then these dots are just instances of students having that GPA, right? And then the students that had that GPA and did not fill out FAFSA are on this bottom of the graph. And the students that did fill out FAFSA are on the top of the graph.
Okay, that makes sense.
And so the whole point of this is to say, okay, I have this data, I want to actually figure out a way to say, based on GPA, what's the probability that someone will fill out FAFSA? Through a line straight down the middle, I'd say, okay, it's like say 100% of students will fill it out if they're below 2, and or they will not fill it out if they're below 2, and then above 100% that they will fill it out, right? That's not actually that accurate. So what we do is we draw a curve here. So it helps you say in the middle there's different probabilities.
Yeah. So like I'm looking, you have a. I'm so used to thinking in 4 points, but looks like if you have 2.0, it's about a 50-50 shot.
Yeah.
And then if you're at a 4.0, you're probably like a 98%, 99%.
Yeah, exactly.
And there's not, obviously there's not a find it, but it's
yeah.
It gives you an idea.
So the nature of all of what we're doing with statistics is we don't know 100% confidence. We have much more confidence at the lower end of the scale, and we have much more confidence at the higher end of the scale. All right, so the next concept is regression. So regression is when we're trying to use data on your x-axis, which is again on the bottom here, to predict a continuous outcome. So we're essentially saying, what is the when I say continuous outcome, what I mean is something that's on a scale between 0 and 10, or say negative infinity and infinity, right? And that probably isn't ever the case for counseling data, but the idea is once we have information on another variable, we can say on average what is the outcome in your dependent variable or your y variable. So to make this a little bit more concrete, an example that we could use is say we want to predict the number of AP classes that a student will take by the number of extracurricular hours that they logged in middle school. This is kind of a crazy example I just thought of, but both things are continuous, right? The number of hours that you spend can be a number or a decimal number, right? And then the outcome will be also a number. And the reason that we use this a lot is that we sometimes, not everything is either a 0 or a 1. A lot of times, another thing that this is useful if you wanted to say predict student income out of college, right? That's another thing that we've seen this used for. Regression is all about fitting a linear relationship between two numbers. So if you remember back to algebra, what we're really trying to do is calculate the slope. Say there's a 1 hour change in the number of extracurriculars per week. On average, how many more APs might that student complete? We good on this one? Okay. So now this is where it gets fun, right? We generally speaking, we have a lot of data about students, and it's not that useful. I mean, it's interesting and it's insightful to compare one variable. But what you actually want to do is we want to compare multiple variables. What we want to say is, say we're trying to predict whether a student will fill out FAFSA again. We want to actually academic performance, their GPA, a non-continuous variable, which is a group, what demographic group are they in, and say survey data. Did they answer that they have a high, high interest in going to college or not? And so what we do there is we take kind of what we had as the basis, right? We're drawing that curved line not in one dimension anymore. We're drawing it in 3 dimensions, or 10, or 20, right? And so in 3 dimensions, you can kind of see what it would look like. You're graphing a number of different variables. But what we're doing, and what I spend most of my time doing at SchooLinks, is we're actually graphing like 50 different variables, 50 different dimensions. And when we add each new variable, we start to increase the certainty that we know that someone will fill out FAFSA. So this one is a little bit hard to visualize, I realize. But does that make sense?
So looking at this model, I'm staring at the 3D model. What are the colors representing? Yes, on that.
So yeah, the colors on this 3D model represent elevation, and so that elevation is actually we can consider that our right. So if you're basically looking on this surface, right, this would be a regression because the outcome is continuous. We could do it in a classification where it'd either be greater than 1, or it'd either be 1 or 0. But here you're saying, okay, I have information about my variable that's on the x-axis and the z-axis, and I want to say predict what the y-axis will be.
We're looking at 3 variables.
Yeah, well, this is 2 predictors and 1 outcome variable. Yeah. So here, I mean, it is really hard to visualize. So what we usually do, and how this ends up being useful for a lot of schools and counselors, is basically what we say is we have all these variables. We're trying to understand each of their relationship to the outcome variable, which is college matriculation, right? And then what we can do is we can say, wow, if we change this one variable more, it will actually have a higher impact. It'll have more of an impact than another variable that we might change to impact the goal. So that actually gives us the levers that we can use to manipulate the outcome. So we can say, okay, like the example that I like to go back to a lot because we've seen it happen, right, is extracurriculars, right? So if you see that students that are involved in more extracurriculars, there's a strong relationship between the outcome variable, which is college matriculation, and extracurriculars, you can say, okay, I have a bunch of different resources in my district. I want to actually deploy more resources to creating more compelling extracurricular activities because I see this relationship, right? Which actually, is a good transition to the next slide, right? So when I say something like that, I'm actually implying that there's a correlation between those 2 variables, right? Oh, yeah.
Can I ask a question on that? So if I work in a K-8 district, and the high school district isn't part of that, and so we want to have a discussion about extracurriculars and the offerings at 6th, 7th, 8th grade, and if there's a direct correlation between that and the number of AP courses that students will take when they get to high school. But those 2 districts, one's it's a separate district and there's a K-8, which is our actual situation. What's the communication and research to be collected to guide that conversation for money allocation or for pumping up extracurriculars at the middle school level? Like the actual, how is that brought in to then guide that conversation, if that makes sense?
Yeah, so I think there's kind of 2 questions there. There's one, how do you do that analysis? How do you make sure that you as someone at the elementary or the K-8 level, right, can connect your data set to the outcome data set at the high school level, right? And so that itself, it sometimes ends up being a large coordination challenge, right? You have to say, okay, I have my data ready. Like I have this hypothesis that what we do will really impact the student's future, and in order to basically go to your school board and request more funding, you need to show that your incentives are aligned with their incentives, right? So that someone will, on their side, do the work to give you that data. Once you have that data, then you're essentially doing that thing that we talked about where you're joining on the key. So you'll have a name, ideally in California. So I'm from Texas. In Texas, we have actually a primary key that will connect a student across different districts, right? So you would basically just connect it and be able to do your analysis with a combined data set. Yeah. All right. So the next thing we're going to talk about is causal analysis. And I was, on the previous slide, what I was talking about before is we were actually looking at a correlation. And correlation, really what that means is you have two variables that vary together, but you haven't established that one actually causes the other. So if you remember back to statistics class or a science class, ideally your teacher would have really beaten it into your head that correlation and causation are not the same thing. And that definitely holds true. So a lot of times what the work that we do with districts is actually going beyond understanding the correlation between two variables. And what we want to do is we actually want to see that changing, like moving one of those levers really will impact some other outcome variable. So elegant technique, it's the simplest technique, and we use this a lot. I really like this technique. It's called propensity score matching. So this is a little bit of a complicated example, but I think one that's really useful. So let's say I am a large district and I send, say, 100 of my students to a local university that is a larger public university, and then I send 100 of my students to, say, a more expensive but also large private university. So I have a lot of data. I know each place my students are going. But I also know that in say, the larger public university, there is a real problem with retention. Students are matriculating, but they're not graduating after 4 or even 6 years. In the private school, they are graduating. So if you take the naive approach, you could say, what would you say? You would say, oh, wow, all of our students should probably try and go to the private university because they have a higher chance of graduating. At face value, that's what you would say, right? But then what we do, and what we do with propensity score matching, is we have to take a step back, and we have to basically calculate a score for each student that goes to each university that indicates their probability of dropping out. So we can actually use this graph here to illustrate it. So let's say on the bottom here, this is the percentage of students, or this is actually the private university where students are staying in school longer. This is the public university where we have a large population of students that end up dropping out. What we've done in each of these bars is we've said all of these 100 students, we've assigned them a score of the probability of them dropping out, independent of whatever school they go to. And we hold out that information about the school that they go to. And then what we do is we say, okay, because the students on the school that have, this is the private university, there are a lot of schools that or a lot of students that were actually going to probably graduate, right? So what we wanted to do is we want to actually come up with a cohort of equal students. So we actually throw out 100 of the students' data, and we only look at 50 students that have equal probability of graduating, regardless of the school that they're in. Because we can say, actually, if we have this equal cohort, what might happen is that the public university that we thought was not good at graduating students actually has a range of support services that really helps those students graduate, right? And we would never have seen that had we not conditioned on this dropout probability and come up with like an apples to apples comparison. Yeah.
Oh, I don't want to, that the systems are changing. The school systems are changing that it's taking them 6 years to get through.
Mm-hmm.
They get rid of remedial courses. Did you know that? Yeah, I just went to a conference where they're trying to solve that problem because of this information. I'm sure that you gave them. So,
I don't know, but I'm happy.
No.
Yeah. I mean, I think
I just wanted to throw that out.
No, I appreciate that.
Yeah.
I mean, the point that I'm trying to make is less about the actually any of those schools are using or any of the schools that are sending their students to these universities are using, but more about how do we assess when we send a student to a university, whether that university is actually increasing the probability that they'll graduate from a baseline probability or it's decreasing it, right? You can't tell by just looking at the aggregate numbers. Yeah. Sorry, this one is like a little bit confusing. I mean, initially it took me a while, but now I've done it so many times that it's like, hey, yeah.
And I'm gonna piggyback on that because I'm really intrigued to see what the CSUs do about that. If those indicators are now gone, so if they took away those indicators to see where those kids should be, and they're just like, yeah, come on in, yeah, well, you know. Well, so it still needs to be addressed because
no, summer they haven't go to the summer readiness. You still have to, you know,
right.
They kind of going around it. You have to sign up for the summer readiness.
Yeah,
that way, but they get rid of the remedial. Yeah,
right.
they starting that.
Because I think it's they just don't want the heat anymore. Of
yeah,
what
you're saying. That's what triggered it. I'm sorry, I wasn't paying attention. So that's what triggered my thoughts about that data because. But it is taking them forever to get through. I don't know. I just.
But and so my feedback because I'm wondering then because they're still going to have to look at some sort of indicator to predict that success. So if the remedial lens isn't as heavy anymore, then what are they going to still look at? Are they going to look at GPI, looking at something to then have predictors of success? Because you can't just start a certain level.
Yeah. I mean,
multiple measures.
Yeah, I mean, when I look at something, well, like when I think about that issue, right, and whether students will be successful, I think it's very useful to actually take away and separate whether students will be successful and whether they'll graduate versus will they get into that school, right? And so when we actually look at data like this, right, you're always going to see that certain students that have are lower performing academically in a higher performing school, there are going to be fewer of them. So that's actually why we have to do a technique like this to understand if we were to really compare equal students in both institutions, we can't use all the data from one institution because they're all lower performing students that ended up in that one. Yeah. A couple more slides here that I'm just going to kind of run through so that we can cover all the material. And then we'll have a bit of time if anyone has more questions or you want to talk about specific things that you're wondering about with initiatives at your schools. So this actually is the question that you posed before on how do we know that when we built a statistical model, it actually is meaningful and actually shows a real correlation or a real relationship? Well, that's what a p-value is. So if any of you remember reading academic research, right? You'll see p-values in that research. And what a p-value is all it's doing is it's saying how certain you are that the finding that you identified in that paper or in the analysis that you're doing. And the reason that we're able to do that is on the variability or the number of students that are in our experiment, that there's always some probability of seeing a result that is as extreme by chance that we saw if there was no real relationship. So the p-value is always between 0 and 1. And if you have a p-value that's 0.001, what that means is only if you repeated the experiment 1,000 times, only in one case would you see an event or like a set of data that's as extreme and as real of an indicator of a real relationship only one time out of 1,000 by chance. So that means you have very good information that exists not by chance, but is really real. So that's the hopefully digestible version of how to interpret a p-value. And then this last thing, machine learning, right? This is something that I get really excited about. And I like to talk about machine learning as really being the process of representing and extracting useful insights out of a large portion of data. In academia, that's actually what they call the definition of machine learning. It's the same thing as, you compress some data on your computer and it takes up a smaller amount of space, but you can still see the same thing after you decompress it, right? And so this is kind of like what got me really, really excited about what I'm doing at SchooLinks, because what happens is every year, millions of students, right? They go through this process and understanding what their own interests are. They figure out what schools' programs appeal to their interests. They figure out what kind of schools they're excited about. They'll apply to a set of schools, then they'll decide, okay, I want to go to a specific school. And basically, when they do that, they create so much data. Every year, students are making so many decisions. And then at the end of that admission cycle, what happens is basically all that data gets thrown out, right? If you didn't write it down or if you didn't collect that in a certain way, you wouldn't be able to analyze it. And in some schools, they're indeed doing it on their own. Schools that have like a lot of resources and maybe someone on staff that's actually building these models, what happens is they actually say, let's take all this data and let's actually understand and take out the parts that will help us cohorts of students where they would be successful, right? And that's actually something that is, in my mind, one of the biggest promises that by incorporating more data and tracking more data about the college admissions and application process, we can actually help facilitate student success with better recommendations that way. We can help give counselors a tool set to understand, hey, I had a student who had the same learning style and similar interests. He applied to this school and he ended up transferring because of this reason. You should probably not apply to this school, but apply to this school, right? That's the kind of thing that, I mean, a human would have to sift through data for hours and hours and hours to come with these connections. But when we use an automated algorithm to do this, we can pull those out very easily and help students make better decisions. So the machine learning techniques that we use, some of them are decision trees. This is an example of a decision tree. We use different variables to say, okay, is one outcome more likely or less likely given a certain variable? So this should actually be familiar because we talked about conditional probability. So a lot of these machine learning techniques, what they do is they layer on different types of conditional probability to help you come up with a more accurate answer every time you run the algorithm. The other thing that we sometimes talk about in machine learning is the distinction between supervised learning, which is when we're trying to learn the optimal outcome, where we have a definition of success, and then unsupervised learning. And unsupervised learning is also kind of cool, but what that is that it's actually saying, I don't know what success is, but I'm just see if there's interesting patterns in this data. So what that'll do is that'll basically try and learn, are there groups of students that are very similar? And if they're similar in certain ways, just knowing that they're similar, help us understand whether they'd be successful in a certain type of school or not. So we use these on a regular basis to actually come up with a lot of the recommendations that we give to counselors in schools. So that's it. I'm going to leave you with a few resources here. This book is actually right outside. This covers more of the conditional probability and the formulating like a whole process in a research design, like we talked about earlier in the session. This is how you can do basically everything we talked about, even the machine learning in Excel, that middle book, Data Smart. And then if you're really interested in becoming like a pro in this, the best tool set is Python. And this book, Python for Data Analysis, helps you use that programming language specifically to do the kind of analyses that we talked about here. And then lastly, SchooLinks, we have actually a podcast called The Path to Higher Ed. And a lot of times we'll have folks on there that are talking about how they're using data in their schools. And just to leave you with a few concluding remarks here, data skills, in my mind, and how effective you're able to be using data is more about your logic and your domain knowledge than it is your understanding of all of the different skill sets or all of the different statistical methods. So you really only need to know the statistical method that you're going to apply, and you can figure that out by talking to other folks, right? Even if you have statistics teachers at your school, or if you want to email me, like a lot of people are really excited about applying statistical methods to student success. So you have the domain knowledge. So I feel like really there's no excuse to not go out and get the help you need to actually do a cool analysis. Then the other thing is you really don't need to learn that much more because 80% of all the statistical methods that we use go back to conditional probability. Very simple building blocks. And then The other thing is tools, right? So you could do all this in Excel, you could do all this, you could learn Python, but a lot of people spend a lot of time building tools so that you can learn from the insights without having to spend all the time doing the analysis. So one of the tools that we always suggest is use SchooLinks, right? Like I spend my days programming algorithms to help predict student success so that counselors don't have to program the algorithms but can reap the benefits of the insights that we've uncovered, right? It's a good system. I do what I'm good at, you do what you're good at. And then lastly, ask questions, right? I'll leave my email up here if you want to ever email me a question, if you're trying to do some research on your own, or just ask your vendors, ask the people you work with that provide the tools that give you data. Everyone is actually really excited about this, and part of the reason I'm here is that I see so much promise in all the data we have to make us more effective. Thank you.
Thank you.